Hi students, welcome to Science Extension. This is Module 3, the Data, Evidence and Decisions, and video number 3 on descriptive statistics. In this video, we're going to look at how you might describe the differences between qualitative and quantitative data sets and the methods used for statistical analysis, including but not limited to descriptive statistics. And in fact, descriptive statistics are going to be the focus of this video. So what are descriptive statistics? Well, these are simple calculations that you can carry out which provide a nice little summary of your data. Descriptions of the characteristics of a data set based on 3 important categories of measurement are usually the ones that we're going to be looking at when we're looking at our descriptive statistics. And they are the measure of central tendency, measures of variability, and also frequency distribution. Now, one of the important things about this course is that it's not a mathematical course. There's an assumption that some of these basic calculations you'll already be well familiar with. But there is an opportunity here for us to start to look at how we might describe some of the data that we've collected in our reports or in our research, and therefore how we might express that data, how we might analyze that data, and come up with some of the important stories that we think the data is telling us. So the first thing that we need to do is just quickly look at what a data set is. So the first thing that we should do is look at data sets. This is just a little snapshot actually of a really good set of data on the Titanic. And it's been used quite a lot for a number of different types of statistics courses because there's so much rich data in this big data set. So a data set is just a collection of data. Does it refer to an organized collection of data? Is it my data or somebody else's data? Well, it's all of these things. So data sets are collections of data. Usually they will be organized in some way, and we'll look at a little bit more detail in other videos as to how we might go about manipulating our data, cleansing our data, doing things that make the data a little bit easier to express, to share, and to discuss and analyze. And also, we're going to look at some of the places where you might find large data sets, large publicly available data sets, which gives us the opportunity to play around with some numbers, but which also might be part of what you think you might use in your own project. And of course, you can generate your own data. If you can come up with an experiment that you think is going to be a useful one to help you investigate a particular inquiry question, then you can collect or develop a method and then collect data that helps you to tell that story, or at least helps you to test your hypothesis. So we said there's 3 important components to descriptive statistics, and the first of these is the measure of central tendency. And central tendency is around this idea of the middle of a data set. And so if we put all of our data into an order, into a numerical order or sequential order, then we can find the very central value, and that is the value that we call the median. So that's the middle, if you like. It is the middle of our data set. When we calculate a mean, we're calculating an average. That is, we add all of our scores together and we divide them by the total number of scores that we have. Now, sometimes there is a reasonable correlation between the median and the mean, and often that's associated with what we call a normal distribution. In fact, when we start looking at some of our testing, a normally distributed data set is one of the assumptions that we might make. But of course, not all data is normally distributed. So sometimes we might find a difference between the median and the mean. And what's that sort of thing likely to tell us about the data set that we are using? If you have a little bit of a look at the diagram here, you can see where we have a nice normal distribution. We've got a nice peak right at that center. That's the mode, it's the mean, and it's the median. So if we put them all in a line, the very central value is our median. The mode is the score which occurs most often, and the mean is all of those scores added together divided by the total number. In a normal distribution, these are going to pretty much occur around the exact same values. However, if our sample is skewed in one way, it's pushed to the right, it has a high tail, or it has maybe it has a very low tail, it has a lot of values towards the lower end, then that value is going to be kinked a little bit out of square. So we might have a mode where the peak occurs somewhere other than the middle value. We might then, when we line them up, because we've got a higher proportion of lower values, we may have a median that sits lower away from that central value than our mean may. It's also the case if we had some larger values up in this end, that they would also be likely to influence our mean. And this is one of the important things when we're trying to look at the difference between the median and the mean. Median is that middle value. It's less affected by outliers. Mean can be quite significantly affected by outliers. And so these might be used differently in different data sets depending on the type of questions that we're asking. Now this, of course, also presumes that we have sequential data that we can put into a numerical order. If we have nominal data, or if we have data where we simply don't have any mathematical relationship between the different groups, often we're going to be looking at something like a mode, and that might be something that we'll talk about a little bit later. So the second important component of our descriptive statistics is variation. So variation in data sets. We talked in the previous slide about the way that the mean, the mode, and the median can be displayed on a graph and how they may all occur in a very similar position, but they may also be spread out. When we talk about variation, we're talking about how the values of our data set differ from one another. We might do something like calculate the range, okay? And this is basically the difference between the largest value and the smallest value. So that would give us the range. So you can see in the little distribution that we put here, the value in red has a much smaller range than the value in blue. You can see the way that these are distributed, we have a much wider variation in our values, in our data for the blue set than what we do for the red set. Another important measure when we're thinking about variation is this idea of standard deviation. And standard deviation relates to how much difference there is basically between each value, each individual value, and the mean value. And so we can find this out by working through a mathematical sequence in order to do this. Now, it's not likely that you're ever going to have to actually calculate this yourself for a set of data, but you may have to interpret calculations that have already been made. So it's important to understand certainly the difference between standard deviation and this other idea of variance, and how variance relates to the standard deviation, and how both of these ways of discussing data can tell us a little bit about the spread of different values. You can see, for example, that two sets of data which both have the same mean, or an average of 100, can have very, very different standard deviations, such as 10. If all the data are very closely distributed, there's a very small range and there's very high mode. And so we have a very large number of values forming a very small graph. Or in the case of the standard deviation of 50, which is our blue part of this graph, you can see that the values are distributed much more widely. There's much more variance in this particular set of data, and therefore there's a much bigger standard deviation than we would otherwise have. So both variance and standard deviation tell us a little bit about the way that the different data points are distributed and their relationship to one another. As a general rule, one of the things that you can note down is that variance is the average squared deviations from the mean, while standard deviation is the square root of the same number. So both of these two values are telling us something about how widely distributed the different values in our data set are. Then finally, the third measure around descriptive statistics that we want to look at is frequency. And would there be occasions where we might actually be interested in the mode being even more important than either the mean or the median? And of course, nominal data is one of the places where that's going to be important, because we can't average makes of cars, for example, or we can't average different colors. So there's no point in some data of carrying out certain types of calculations, statistical calculations, because they're just not going to be relevant. But we might be very interested in the mode. We might be very interested in the most common response to a particular question. So that means that we may not choose to include every single piece of data. In fact, if we're looking at grouped data, we might even look at how we might put some values together so that there's not the sort of same numerical relationship between them, or even though there is an order about this data, we can still see that we can get a nice sort of normal distribution curve out of this sort of data, even though we're now looking at categories rather than straight numerical data. So there's a couple of examples again that we might look at when we're talking about frequency data. The first one is a frequency table. And this is a good way of taking a lot of raw data and organizing it in a way that's much easier for your reader to understand. You might also look at grouped data, such as we have here, different things in different groups. Just means that we may have a huge number of different values that we want to try and condense when we're showing these on a particular graph. So that way we can do that by condensing the data down and grouping it together into different subgroups, if you like. And of course, we can use a frequency distribution chart like this one to give us a little bit of an idea, a nice quick visual of exactly what's happening or how our data has been distributed. It's important to be able to understand some of the different types of descriptive statistics that you may use, but we're also going to need to go beyond descriptive statistics. We're also going to need to start asking questions about our data. But before we do that, we need to have a little bit of a look at some of the different ways in which we can display our data, and we'll be doing that in the next video. Thanks for watching.